So for this problem, we need to find the inverse of our matrix A, which is 2, 4, 0, negative 1, and then we need to check our answer. So for the first part, we would write our matrix A on this side and then our identity matrix on the other side. So what we want to do here is we want to get this matrix in the form of the identity matrix. So our first step is we want to get this 4 here to be a 0. So to do that, we need to do some row operations. So we have row 1 is equal to row 1 plus 4 row 2. And then when we do that, it gives us 2, 0, 0, negative 1. But we can't forget that we also need to apply this row operation to this matrix as well. So when we do that, we get 1, 4, 0, 1. But we can see that we're still not done yet, as this side of the matrix is not the identity matrix right now, the way that it is. So we can apply 2 row operations at once here. So we have row 1 is equal to 1/2 times row 1, and then we have row 2 is equal to negative 1 times row 2. Because when we multiply 1/2 times 2 gives us a 1. When we multiply negative 1 times the 1 over here gives us a 1. So 1/2 times 2 is 1. 1/2 times 0 is 0. And then negative 1 times 0 is 0. And then negative 1 times negative 1 is 1. So we're looking pretty good here. Now we have our identity matrix on the left side. But we can't forget that we also need to apply these row operations to the matrix on this side. So when we do that, it gives us 1/2 times 2. And then we have negative 1 times 0, which is still 0. Then negative 1 times 1, which is negative 1. So this is our inverse matrix. But we still need to check our answer. So to do that, we would need to multiply our matrix A times the inverse that we just found, and then we would need to make sure that when we multiply the inverse first times matrix A, that it still equals the identity matrix. But just for the interest of time, we are just going to multiply matrix A times the inverse matrix that we just found. So we'll go ahead and rewrite those real fast. It's a little too big. 2, 4, 0, negative 1 times 1/2, 2, 0, negative 1. So I like to draw a big matrix beneath just so I can keep track of my work. So to start, we need to multiply the row here by the column here and add the corresponding elements. So we would have 2 times 1/2 plus 4 times 0, which gives us 1 plus 0, which is 1. Then for the next entry over here, we do kind of the same thing. So we would match up the row over here with the column over here. So we have 2 times 2 plus 4 times negative 1, which gives us 4 plus negative 4, which is 1. Oh, sorry, 0, which is 0. So then for this next entry down here, we would do the same thing. So we match up the row with the column over here. And we have 0 times 1/2 plus negative 1 times 0, which gives us 0. And then for this entry right here, we do the same thing. We would multiply, use this row here and this column here. And so that gives us 0 times 2 plus negative 1 times 1, which gives us 1. So our final answer is 1, 0, 0, 1, which is what we were looking for. If you were actually checking this, you would want to reverse these two and multiply your inverse matrix by the original matrix A, just to make sure that you get the identity matrix both times. And that's it.